Hello, welcome again. We are solving some questions of fluid mechanics and machinery. The topic is hydraulic machine. Question number 5 is a horizontal strikes a frictionless vertical plate. The plan view is shown in figure. It is then divided into two parts as shown in the figure. If the impact loss is neglected, value of theta. Option A 15 degree, option C 45 degree, option D 60 degree. So this is your Q naught and this is angle theta with vertical. This is Q1, this is Q2 and Q1 is given as 0.25 Q naught. Okay, so now the total discharge is Q naught. Okay, and it is divided into two parts Q1 and Q2. So Q naught is equal to Q1 plus 0.25 Q naught, so Q2 will be 0.75 Q naught. Okay, so as the total as a force on the plate parallel to the plate will be zero because there is no impact. So, so rate of change of momentum in x direction will be zero. Okay, so rate of change of momentum will be zero. So initial momentum in x direction is minus initial momentum in x direction minus final momentum in x direction will be equal to 0. So initial momentum as this jet is making an angle theta with the vertical, so initial momentum in x direction will be q naught uh, q naught v is the velocity, q naught v sin theta, and the final momentum in x direction is in this positive direction is q2 v and in negative direction is q1 v minus q1 v. So it is it is in positive direction it is q2v, in negative direction is minus q1v. As we have to subtract the final momentum, so we will take the positive sign, so it will be minus q2v plus q1v. Okay, so that is q2v minus q1v is the final momentum. As final momentum has to be subtracted, so we have to change the sign. So q2v is your point sorry uh, we can take v as common and put q2 as 0.75 q2 q naught and q1 as 0.25 q naught. So from this we can find out the sin theta. Sin theta is your zero point 0.5 or it is 1 by 2 or theta is your 30 degree. So answer is 30 degree. Next, question number 6. A tank and a deflector are placed on a frictionless trolley. The tank issues water jet. Mass density of water is equal to 1000 kilogram per meter cube, which strikes the reflector and turns by 45 degrees. If the velocity of jet leaving the reflector is 4 meter per second and the discharge is 0.1 meter cube per second, the force recorded by the spring will be this spring will be option A 100 Newton, option B 100 root 2 Newton, option C 2000 Newton, 200 Newton, option D 200 root 2 Newton. So this is your spring, and spring is in horizontal direction, so we have to determine the horizontal force exerted by this jet. So as deflector can be assumed as a fixed plate. So we and this deflector is making an angle 45 degree to this. Okay, to the jet. So we can assume a jet, assume the normal component of jet as v sin 45, and this is the initial velocity of the jet and final velocity of the jet perpendicular to the deflector is 0. So change in velocity of the normal component is v sin 45. Okay, so the force exerted on the deflector is your, again it can be treated as a fixed inclined plate. Okay, and it will be, so rho q is your mass product and change in velocity perpendicular to the plate is uh, v sin 45 minus 0, because final velocity is 0, initial velocity is v sin 45, as velocity is v in the direction. Okay, or we can assume that it is initial velocity v sin 45 in this direction. Okay, so this will exert a force Fn, or okay, force Fn, and Fn is given by rho q v sin 45 minus 0. or rho q is uh, rho is density and q is mass flow rate, that is point 0.1, that is given. Mass flow rate is given, discharge is given, so mass flow rate is rho into q, that is 1000 into point 0.1, that is 100 kilogram per second. So Fn will be your rho q v sin theta or 4 sin 45. Okay. So this is the force in normal direction, or it is the force in this direction. Okay. Similarly, like in fixed plate, fixed inclined plate, we can find out the force in this direction by taking the sine component of this. So it will be 100 into 4 sin 45 multiplied by sin 45 in x direction, and this x component will be the force on spring. Okay, so that is 100 Newton. So answer is 100 Newton. Next, a frictionless fluid of density rho flows through a bent pipe as shown. If A is the area of cross section, if A is the cross section area and B is the velocity of flow, the forces exerted on the segment 1, 2 of the pipe in x and y direction are respectively. This is 1, this is 2, and this is the bend. Okay. Option A rho AB square 0, option B rho AB square root 2 rho AB square, option C 0 0, option D 0 1 by root 2 rho AB square. Okay. So in x direction the velocity, initial velocity is v. Here is final velocity is also v. So there is no change in velocity in x direction. And in y direction the final initial velocity is v, and final velocity is also v. And there is no change in direction of the velocity or and of the magnitude. So the there will be no force in x direction as well as in y direction. So answer is option. Answer is C. Okay.